Thank you. Great to be back. So this is, to some extent, a continuation of the Vega integration session that was done yesterday. And the focus here is to showcase that the observability domain, which is, as we'll discuss soon, a complex domain, which has multiple points of view and multiple dimensions. And as a goal, we need to simplify that for our users. So we need to give a very comprehensive and yet simple and intuitive way to move from one perspective into the other. And we'll try to prove technically today that this is possible within using the existing dashboards and, of course, using Vega components. So just we'll overview the complexities of observability and the observability domain that we have today. We'll obviously discuss OpenTelemetry, which is a key factor in the observability domain. And we'll discuss how in OpenSearch we've adopted the OpenTelemetry, how we're using OpenTelemetry, and how we're using the OTel demo as a proof of concept of observability, and how we can leverage these components building your own observability telemetry dashboard and monitoring that. So just a brief review. What is observability? So observability is the capability to understand a system from an external point of view. You're an observer, not necessarily knowing the internal of the system. You're receiving telemetry data points. Some of them are aggregated, some of them are discrete. And you need to understand the system behavior. And you need to be able to ask questions. These questions are not only relevant to the point of view on what you're asking, but they're also arbitrary to the extent that some events are unknown and some events are dependent on aspects that you're actually not aware of. So the question has to be take the ability to ask a diverse and very unknown world. And all of these constraints we have to simplify as a user, as an engineer that needs to solve questions, how to do that efficiently, quickly, and very insightful with the help of the UI. So let's just imagine a day in the life of a site reliability engineer. You wake up early, or there's an alert that wakes you up in the middle of the night, and you start going into the monitoring system, to the metrics, and start to understand what's going on. So metrics gives you an aggregated view of something that is occurring, a trend, or some threshold that is being extended. And you need to understand, first of all, what is the time frame for these occurrences? Is this something happening now? Is it something propagated from similar events that happened before? So the purpose, first of all, is to understand and correlate the time zone for which the event has occurred. And then the process goes on. So you think you have an idea of what's going on. You understand, okay, this is the metric that represents the issue, the error, the incident. I need to correlate that with a different metrics to just understand whether this just started now or is it propagating. Now that I have that information, next I need to just pivot a bit and deep dive into the data itself. So I've watched aggregated data. I'm going to see data points that are residing within logs to understand if these logs that represent metrics, that represent data points on different contextual information, are they sufficiently informative to give me some hint of what is the system doing, what is going on in the system. So these observations are related to data points, and these data points have structure. And what is the structure of observability? So the three famous pillars, which are, we can say them all together, traces, metrics, and logs. This is the famous three. But it's not only this. There are more than these. There are the events, there are profiles, there are exceptions. There are many types of data points that have distinct properties and distinct use cases. But the three major ones that are supported out of the box almost in every observability frameworks are the traces, metrics, and logs. So what are traces? What are metrics? We've discussed this before. Metrics are aggregated value. They represent a summary or a histogram of data points. They represent mostly a trend or a specific aggregated item that you'd like to understand how it behaves along a period of time. And it also contains attributes. And that is an important part because attributes can help us identify things which are above the context of that what we're currently examining. So attributes has a temporal context, which is the time that has occurred. They have a contextual representation which may be related to the operation that these metrics are measuring, and sometimes even have a global attribute such as information on the context of where they're running, which is if it's an environment such as cloud-based or containerized, can have information on the pods, on the region, and so on. Now going into logs. Logs are a different perspective. They represent a single point in time or a stream of happenings that have sometimes a very brief occurrence, or they represent some part of an occurrence that is happening within a transaction or within an operation. So let's think of an HTTP request. An HTTP request is logged by some service, some container, and it's emitted with additional information. These information attribute, these information points, give me information which is also relevant to this point of time, which is a timestamp, an ID, something that represents that occurrence in time. But they also have more generic information, such as, is this a part of a longer transition? Is this a part of a longer operation? Is this a part of a contextual of doing something between the user and the service itself? So we have a bunch of related attributes, and each one of them represent a different perspective. And why is it important? Because these attributes are our key and our helping factor to do the correlation process. And the correlation is the fundamental way in which we are investigating our system health. We are determining the root cause analysis. We are understanding the behavior of different components within our system. So here we come into traces. And traces try to take these two concepts of the temporal and the longer phase and correlate them according to few key parameters, which are the trace ID, which represent the entire transaction, and the span ID, which represent that specific operation. Traces, by the way, when they're formed of spans, these spans themselves can have sub-operations, which are events. And there's an example how you can see a trace within composed of different spans, and each span have its own operation, its own sub component that activates it. How do we do observability today? So first of all, we do OpenTelemetry. And the first question is, who is familiar here with OpenTelemetry? Okay, and who has used OpenTelemetry? Actually in project? Okay. So OpenTelemetry is a foundation CNCF project. It's still incubating. It came into reality in 2019, and it was emerged from two leading projects. One in terms of metric, which is Open Sensors, and the other one is Open Tracing by Google. And these projects converge into one framework, which is the OpenTelemetry. And since then, it became prominent. I think it's the second prominent project in the CNCF. It is a community standard. Every observability tool, and I think most of the industry is adopting OpenTelemetry as its standard, and obviously OpenSearch has adopted that as well. And I think one of the key parts of OpenTelemetry is the using the schema as the main engine to create the advantage forward, which is the OTel protocol. That schema is combined of the three pillars that we've discussed, but it also contains many other semantic conventions, which are the actual attributes that are carried on between different data types and different telemetry data points. What does OTel contains? It contains a collector which allows to collect different data points from different vendors. That it contains the schema, as we discussed before, and it has a very easy and convenient way to instrument applications and instrument services using either a library, very rich and good libraries for different frameworks and different languages, and also using zero code-like annotation that helps instrument without actually going into the code, for you have historical libraries or any other things that you cannot manually go and update the code or add the logs directly. So the collector, just to brief review what it can do, it can collect multiple data points from the emitting entities. For example, we have database that emits data, we have exporters that emits data, we have different applications that emit data, and all of these are collected into a single point. That collector can be scaled in the sense that it can withhold a very large volume, and it has the ability to export the data into multiple data stores, Prometheus, for example, OpenSearch, and others. And a key advantage is that these these pipeline enable to do very sophisticated processes such as sampling and downgrading the amount of data, so you can have a very efficient mechanism to get the data in a very prominent way and very efficiently correlate data coming from different services, and using these, as mentioned, these correlation ID, which are trace ID, span ID, and so on. Semantic conventions are one of the key changes that, as discussed earlier in Kevin's presentation, we need to have a unified and common vocabulary for attributes. If we're discussing different applications that referring to the same concept as an IP, as a service, we need them to correlate on the naming convention and on the size of the attribute and on the meaning and the type of the attribute itself. And OpenTelemetry has supported the merging of ECS, Elastic Common Schema, into that unified vision of attributes. So for example, we discussed HTTP. What does HTTP contain? It contains a list of attributes, and each attribute has a name, a type, an example, and a stability. So if, for example, we'd like to use that attribute as a mechanism to investigate later, to store, to index, and to use it as a correlation, for example, an IP or a HTTP method, we can use it that we know all of the types of data points that we're receiving, whether they're metrics, traces, or logs. If they have that specific attribute, they will share the same properties, and we can use, as mentioned earlier, a schema in OpenSearch and mapping to facilitate them, and use the same type of query to search them across whether it's one index or multiple indices. So now is the technical part of this talk. How do we put this information together? So we know we have multiple points of views. We have metrics, we have traces, we have logs. We know that we need and we can correlate them either by the building correlation ID, such as span ID and trace ID, or there's the dimensionality that we know should match because OpenTelemetry semantic conventions has dictated that they match and they use the same vocabulary and the same naming. What can we use to present them? We can build, obviously, dashboards. But a single dashboard, unfortunately, today cannot represent all these types of perspectives and types of pivoting between one perspective to the other. So we need to create some sort of a workflow. And that workflow would be combined of multiple dashboards. Each dashboard have its own perspective, and we need to tie them together. And that's the actual problem or challenge that we have today, how to tie them together. So first of all, we need to have a unique name. So each dashboard will have a unique name, and that name would function as its purpose. That name would function as a URL navigation, so we can copy-paste the URL that contains the name of that dashboard, and that dashboard would remain the same. That means, by the way, that if we import that dashboard, we should not let the import mechanism, the dashboard importing mechanism, saved object, to rename it in a random name, but we have to override the naming so it would contain the same name that we expect it to be. And as Kevin showed earlier, we will use the index pattern navigation capability so that each component, each field, whether it's a trace ID, span ID, HTTP, as Kevin showed earlier, each field that can be associated with a different dashboard will be associated, and once selected, that dashboard would be navigated to with that specific ID of that, whether it's a service name, an IP, trace ID, and so on. So for example, here trace ID, I select the trace ID, and I'm immediately being navigated to the traces. The next part is not only linking through selecting a category or a specific field, but actually being able to show a header visually and allow that header to be selected. And once selected, you're navigated to that specific dashboard. And this is where we are using Vega. Vega allows us to integrate a very sophisticated vocabulary, and using that vocabulary allows us also to navigate into a specific dashboard using the context, to propagate the context of our existing filter, including whether we have filters on services or whether we have filter on time frame. So this is an example, and here we can see that the first dashboard is an ingestion rate dashboard. It has a time filter, it has a time range, and if we select the next part, the next phase of the step, it navigates us to the next dashboard, which is a better zoom in on what's going on in the system. We can see that we have traces, list of spans, how it breaks down into multiple spans, and we can also navigate within the actual graph network of the services by selecting a service and continuing this navigation, this process to the next step. While this process is navigated, we continue to carry out the context of that filter, including the context of the time. And we can continue to navigate. So the idea of having the flow represented visually and having it being able to select that steps in the flow and understanding where we are currently, that's a fundamental key of creating a very live and interactive dashboard that includes these steps. Now let's discuss the OpenSearch and OpenTelemetry interaction. We have adopted the OpenTelemetry demo, which is a demo application that showcases many services that interact together to create sort of an astronomy shop. It interacts with multiple technologies. It has Kafka, Redis, it has Golang, it has Python, it has almost all the technologies. Some of them are using instrumentation, some of them are directly writing code to OpenTelemetry framework, and they try to emphasize the capability and importance of using OpenTelemetry. The outcome of this demo is writing data directly into OpenSearch, and once that data resides in OpenSearch, we can install, using the integration framework that Kevin showed earlier, we can install this demo application that shows the workflow, which helps navigate between different aspects of the telemetry information. We can see the services. We can navigate, drill down from selecting each services to see how the spans within that service are occurring. We can select the specific trace ID and see how it behaves according to time, and so on. As I mentioned before, making this something viable needs to incorporate visual elements. So one visual element would be the header that is based on top of each of these dashboards and creates a navigation mechanism transitioning from one step to the other step. And there is a link here that shows the actual, gives an example of how that specific Vega component is built. It explains what parts is needed to create this linkage. And Vega allows us to create this linkage between different components using the context of what we're currently selecting. So if we're selecting, let's say, a component which is a service, that service would be contextualized within this navigation process and can also be added as a filter. So to sum up what we have today. So we have a very sophisticated mechanism of creating logs, metrics, and traces by OpenTelemetry. We know how to ingest them. We know how to index them. We know how to correlate them. And we need a very good, easy, simple, and appealing mechanism to demonstrate that to the user and to bind them all together within one flow, which is composed of multiple dashboards. And I hope I've given you some capability today, technically, how to make that possible today. And I think the shout out here is that we are in the dashboard team and in OpenSearch as a whole trying to improve constantly what we're doing. And part of that is to suggest ideas and RFCs and issues that will help navigate these steps through. And I've created a link to some of them. And for example, the dashboard modernization RFC, which describes some of these things that I've discussed, like drill down and navigation in practice. So I'll be very happy if every one of you who is interested can comment and open an issue and address these issues, because they are interesting and they are part of what we do every day to help users interact with their data. Thank you, and I'll be happy to answer questions.